Did you know the ocean's average salinity is about 3.5%, so every liter of seawater contains nearly a handful of dissolved salt? But where does that salt come from? Most of it is born on land. Rainwater erodes rocks, freeing ions like sodium and chloride that rivers carry toward the sea. But if rivers are constantly delivering salt, why aren't they salty? Because rivers are fast-moving, dilute, and short-lived compared to the ocean, so salts don't have time to build up. Fresh water flushes them downstream. We know this from decades of river sampling and geochemical studies that measure ion concentrations along river paths and compare them to seawater. To understand long-term accumulation, scientists use mass balance and statistical models, plus isotope tracers and laboratory experiments on rock weathering to estimate inputs and outputs. These methods show that while rivers add salts continuously, the ocean holds them for millions of years. Its residence time for many ions is enormous, so small inputs accumulate into high concentrations. Meanwhile, some salts are removed, organisms use ions, minerals precipitate as evaporites in shallow basins, and hydrothermal reactions at mid-ocean ridges lock ions into new rocks. Evaporation on the ocean surface also concentrates salts because water vapor leaves but dissolved ions stay behind. The water cycle, led by solar energy, selectively moves pure water into the atmosphere. We piece this story together by combining field observations, controlled experiments that simulate weathering, and global chemical budgets that test whether input equals output. That scientific triangulation is why geologists can say with confidence that the ocean became salty slowly over Earth's history, not overnight. So the salty sea is a memory of billions of rivers adding tiny amounts of salt for millions of years, while rivers themselves stay relatively fresh because they are the delivery trucks, not the warehouse.